Hello students, the next video on law of conservation of momentum. Okay, in this video we will try to do some applicative problems, numericals. You know already, according to the law of conservation of momentum, the momentum before collision is equal to momentum after collision. Now what is it simply in terms of statement? m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay, so this is initial momentum and this is the final momentum. Now I thought I will do a small demonstration. I got two balls here with me. One is, let us say, yellow ball and another is orangish ball. Now these are the two bodies. The mass, this m1 and the orange body, you call it as this one, and this is orange and this is yellow. Fine. So this is m2. These are the two mass bodies. They are going to collide. They are going to collide. For example, this body is at rest and I hit it. Yes, it is coming with the initial velocity. u1 is there, u2, the body is at rest, means it will be 0. Suppose if this body is already traveling and this body is coming and hitting, u2 will have certain value. You can easily see, for example, a scooter or a bike is going, let us suppose, right? And a bike is going and behind a car is coming, right? And the car is coming and hitting this bike, let us suppose. Then what will happen? The collision, the hitting, the collision will change the momentum. So we call it the accident. An accident has happened. Yes. So like that, here also two bodies are going to collide with each other. Suppose if I say this body is at rest, let us say the second body, that is u2, is at rest now, and I take the first body and I hit this body. You all would have played marbles, you know, marbles. Or for example, carom board. In carom board, what you do? You are having lines here, right? And there is a striker which is big, and you have got a small coin, and you hit this and it goes into the pocket and falls in it. You use different ways of hitting it so that it reaches the pocket. Yes, but we are not using a coin to hit a coin because they are all having similar mass. So you can do it, nothing wrong. But a striker which is heavier and bigger, that is used to strike a coin. So these are all collisions basically. Fine. Now what I am going to do further, I am going to take these two bodies and try to hit each other. Right? Now, see, these two bodies are there. Orange body is m2, this is body. Suppose if I hit it with a small speed, or if I hit it with, yes, now what happened? The one body is going forward, other bodies are trying to rebound back. Yes, anything can happen. Two bodies are there. So this final momentum will depend on with what initial velocity, and the body is at rest or not, or the body's mass. It depends on all these factors. Suppose if I take a bigger ball, yes, I have got a volleyball. Okay, now I got a volleyball here. Now I hit this with, let us say I got a bob here. I can hit it with the bob. Now you see what will happen. The bob is heavy. Yeah, the bob is metal. And this is a big body, right? Or you can reverse it like this. I can reverse it. And you can do multiple experiments. For example, all your games and everything is based on this momentum, projectile motion, velocity, all this. Suppose if I take like this and give a punch to this ball with a particular force, let us say. So this is having mass. Okay, my arm is having a mass and I am going to give a velocity and the body is at rest. Suppose the body is already moving. In volleyball, what you do? It's moving. You do like that. Okay, so like this, different combinations, the collision can take place, and it can produce different types of results. That also we have to be clear. Right. Now I say, suppose these are the two bodies, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now there can be another case, for example, right? I have got a duster here and there is a girl, let us say. Now duster, you can take a skate, for example. A person is coming with a particular velocity and the skate is at rest, and when I stand on that, the both bodies coalesce together. The body coalesce, C-O-A-L-S-C-E, coalesce together. Check the spelling please, right? And coalesce together and go together. They go together. That means what will happen to the final velocity? V1 is equal to V2 is equal to some common value V. Then the formula will become m1 u1 plus m2 u2 is equal to m1 some v plus m2 v. That means it is a common velocity. Or we can say m1 u1 plus m2 u2 is equal to v is common factor. So I can say m1 plus m2. So this is when the both bodies join together, they hit together and go together. At that time the final velocity will be common velocity. Now I want to do one more small experiment. Okay, let me try. I am not sure how far you can see from there in the video. I got, this is all improvised technique. In the classroom or in the lab we can do with scale. Two scales we can keep, a meter ruler in between. I am going to take these two bobs. Okay, so what I thought is, from there I hope you can see. I will send one of them here inside and I am holding it. I hope you can see it. Wait just a minute please. Yeah, yes, can you see this bob here? There is a bob here. Yeah, metallic bob is here. I am holding the bob with my finger like this. There is a metallic bob. I take this one. Yes, and I am going to give a particular velocity to this body. Yeah, this body is there. What is happening? You watch carefully now. Yes, now I am going to release this. Yes, it has gone and stopped there. Now again I bring it back. Yes, again I send it one back to this. Because these experiments requires more velocity. This is a heavy bob. Yes, pendulum bob. Yeah, watch carefully. Now I take this carefully. Let me try. I am just only trying. I am not sure. No. One more time. Last time. No. No last time. It is hitting each other. Going with a particular speed, still going. Yeah. The first ball is gone that side and second ball is only here. These are different ways we can study collision. Okay. So let me do a numerical. Unless and until you see something, you observe something, you cannot understand. Yes, that is why I try to do some of the possible practicals for you. Right. Now what I am going to do, in page number of 9th standard textbook, page number 124, example 9.6. I am going to do this numerical for you. Yeah. Example 9.6, page number 124. These are all very important, basic. So 11th also you should try to do this. A bullet of mass 20 gram. You have a pistol, gun, and you have a bullet. Yeah, pistol is there. I'm going to use the rifle, shoot something. Fine. Yeah, not a human being, maybe some crow, let us say. Yeah, but you should not do all that. Just I'm telling you. Okay. There is a pistol and there is a bullet. Yes. And the mass of the bullet, what is the given data? Mass of the bullet, M1 is equal to 20 gram. SI unit, multiply by 10 power minus 3 kilogram. Is horizontally fired with a velocity u1 is equal to, yes, fired with a velocity 150 meter per second. This is not u1 actually. This is really v1 because it is moving with this velocity. Before that, the bullet and the pistol, the whole system was at rest. The whole system was at rest, right? Both of them are not moving. If you have a doubt, I want to say, if you think that this is the pistol and this is the bullet, both of them were at rest first, okay? They both are at rest. Now, when you pull the trigger, the bullet is moving with the velocity of 150 meter per second. 150 meter per second. But this is there. What is going to happen to this now? Let us see now. Okay. Now, will it move or not? We should see. So, this is the final velocity. Now, M2, mass of the pistol is 2 kilogram. So, no need to change. This is gram, this is kilogram. And what is the recoil velocity? What is the word? Recoil velocity. Dear students, let us be clear about it. When you join army or navy or air force, or whenever you use a pistol to use it. For example, if I say, okay, this is the pistol. Will I keep the pistol like this and shoot like this? No. You will keep it like this and I trigger it, tuck, your nose will be broken. No. When you are given a pistol, right, and what you do, first they will teach you, this side is a little hard, okay, they will teach you to keep it on your arms. Why? I pull the trigger and the bullet is going in forward, right, and this will come backward, recoil. This is called recoil. Not so much, yeah, it will recoil, depends on the heaviness of the system, bullet and the pistol system. Okay, so you can't keep like this, damal, right? Your nose, it will break. No, not like that. First they will tell you, your arms are there, keep it on your arms like this and hold it like this. Tick. Then when you do, small, little jerk will be there, and that is called recoil. What is it called? Recoil. Now let me do the numerical. Yes, I take the law of conservation of momentum. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. We know this. Initially the system is at rest, so this is 0 and this is 0. The value has come 0. So 0 is equal to M1 is how much? 20 into 10 power minus 3. 20 into 10 power minus 3 into what is the final velocity? 150. 150. Put this in a bracket. Plus M2 is how much? 2 kilogram. That is the pistol. Multiply by V2. We don't know, unknown quantity. Now let us solve this. 0, 1, 0, 2, 0. If I keep it 1.5, 3 zeros will be there. This will get cut. And I got 1.5 multiplied by 2 plus 2V2 is equal to 0. That is 0 is equal to 3 plus 2V2. Or I can say 2V2 is equal to 3 comes this side minus 3. Or V2 is equal to minus 3 divided by 2. That is equal to minus 1.5 meter per second. So this is the answer. Why there is a negative sign? Negative sign means what? Positive is going forward, negative is coming backward. That is recoil. The forward direction, the velocity is 150, but the rebouncing is only 1.5. Your shoulder can withstand. Your shoulder can withstand. This is the recoil of the gun. I hope you understand this problem. Very interesting, very important problems. Yes, let me try to give you the next problem also. I will try to do. What is the next problem? Is problem number 9.7, page number 125. Doing numericals is very important. So to get the concepts clear, kindly do the numericals, please. Yeah, I am doing only simple numericals. 9.7, page 125. A girl, see, I am showing you the picture here. A girl of mass, what is the data given to us? Mass, girl of the one, M1 is equal to 40 kilogram. Okay, she jumps with a horizontal velocity. So U1 is equal to 5 meter per second. On a stationary cart, we don't know the mass still, it is stationary, so U2 is equal to 0. Mass is 3 kilogram, cart is 3 kilogram. What is their velocity as the car starts moving? What will happen? The cart is like this, okay, like a skateboard, and the girl comes and jumps on it. Fine, and now both of them are going together. That is a common velocity V. So V is equal to how much? Right? Now assume that there's all the things you forget it. Yeah. Extra data you don't need. Let me keep the book aside. Very carefully let us do. What is law of conservation of momentum says? Law of conservation of momentum says M1 U1 plus M2 U2. The momentum before collision is equal to M1 V1 plus M2 V2, momentum after collision. M1 U1 plus M2 U2. U2 is 0, so I can leave this factor. So leave this factor first itself is equal to, both of them are joined together. So M1 plus, okay, for you I'll use one more step, M2 into V. That is equal to M1 U1 is equal to M1 plus M2 of V. Yeah, some collision happened. Right, now I want to calculate V. M1 U1, M1 is 40, M1 U1 is equal to M1 plus M2 together into velocity V. M1 is 40 multiplied by U1 is 5 is equal to M1 plus M2, M1 plus M2, 40 plus 3, 40 plus 3. This is 40 kilogram, the person is, girl is, 3 kilogram is the skateboard. Into V we don't know. 4 5s are 20, 200 is equal to 43 into velocity. So velocity, final velocity is equal to 200 divided by 43. So V is equal to, I think you should do this, but anyway I will try to do it here, 200 divided by 43. Okay, 5 times it will not go, 4 times. Nam 1 12 2 midi 1 nannang 16 1 17, right? Okay, what is the difference here? 8, and here it is a 9, that is 2, 28. Point, okay, point. 0 you add, nannang 16 7 nang 28. 6 times you will try. R1 18 kettu midi 1 6 24 1 25. Right? Q. Reminder 7th again 222 220. Again R nang 24 I nang 20. I mun 15 midi 1 I nang 21. Enough. Don't go beyond this. Right? After digit point, 2 digits are enough. 5, which is approximately equal to 4.7 meter per second. So both will travel with a velocity, common velocity of 4.7 meter per second. Okay, dear students, I hope you understand what I have taught you. I want to tell you something. Physics, you have to learn with activity. Last 35 years I am teaching physics only through activities. I started from 6th to 7th, 8th, 9th, 10th and 11th, 11th, 12th. I don't teach beyond that. I want you to see an interesting video about all these things also is a classic physics professor, yes, Sir Walter Lewin. Okay, he's a fantastic physics professor, right? And I think you should watch, I think Princeton University or something like that. You watch some of his wonderful videos. He teaches with all kind of, what you will say, demonstration. Through demonstration, you will understand better. I tried my little best with this kind of videos. Thank you so much.